name is Barney Drilling. Some of these models are, well, it's a variation of models here. We have down the end a hot air steam engine, a couple of gasoline engines here. We have a model of a 1890s milling machine that gives you a good idea of what they had to deal with for machinery back 150, 60 years ago. Down a little further you'll see this one operating as a representation of a steam drilling engine. They used to use them in the oil field for driving the well points down.
That's a Stirling cycle engine. That's a Stirling cycle engine. There are two Stirling cycle engines right there. They all work off the same principle. Any Stirling cycle engine works off of the temperature difference between two surfaces. This one works off the temperature difference between these two plates. This plate is heated by the candle. This plate is at room temperature. That piston is in there is called a displacer piston.
Oh, I see. That's
there's about an inch.
I didn't see the plastic wall.
Yeah, that's just a styrofoam piston. And there's about 1/8 of an inch clearance between that piston and this clear plastic cylinder. Its function is to move the air back and forth between the hot plate and the cold plate. When that piston is up, like that, all the air in this closed container, remember that's a closed container, it's always working on the same air. All the air is being heated by the bottom, it's down here being heated by the hot plate. Heating the air in a closed container, it expands, it wants to go somewhere. So it expands over into this cylinder, expands past this piston, over into the hole that plays into this cylinder. And expanding air pushes this piston out. But when that's happening, this piston is moving down to move all the air up in contact with the cold plate. You're now cooling the air in a closed container, creates a vacuum. This piston is up here, it's got a vacuum underneath, atmospheric pressure pushes piston down into the vacuum. Okay? The same thing is happening here. This is a Stirling cycle engine. You've got a power cylinder here, just like that power cylinder there. You've got a displacer piston inside that cylinder right there. One end of that cylinder is being heated, like this one down here. The other end of this cylinder is being cooled by this water. When this displacer piston is up, all the air down here being heated. It's expanding into this piston or into this cylinder, pushing this piston out. At the same time, this piston is moving down to move all the air up into this end of the cold cylinder. See this water in here? That's keeping this end of this cylinder cold. You're cooling the air in the closed container, creates a vacuum. Atmospheric pressure then pushes the piston into the vacuum.
My name is Arthur Dell. I've been to the show here before and I decided this year to display these fans. These are all from about 1900 to about 1920. They're Stirling cycle fans. The principle behind them is there's air trapped inside of here. You've got a power piston and an air transfer piston. The air transfer piston pushes the air from the hot side to the cold side and back and forth. When the air transfer piston goes all the way up to the cold side, all the air will go down to the hot side and it will expand, push the power piston. Then the air transfer piston pushes the air to the opposite side. The air contracts, it'll pull the piston back. So you basically reheat the same air over and over again, heat and cool, and it pushes the power piston back and forth. These are all working on the same principle. The early ones are very low horsepower though. That's why they use for purposes like these fans or whatever.
So if you want to get it up, you bring it in there.
Hi, I'm Ed Ferguson from Deering, New Hampshire, and I'm selling a rough array of precision measuring instruments. Balls out of ball bearings, extreme precision ball bearings. What anybody would do with them, I don't know, but that's of such precision, it's sacrilegious to throw them out. And other bearings, just as somebody wanted one to look at what a bearing looks like. And that's about it, but dial indicators and precision measuring instruments.
How'd you get involved with this?
I've always been in this. I've been a toolmaker for roughly 50 years now, and the American Precision Museum is only 2 hours away, so I try to make it almost a second home because I'm just thrilled with old equipment and this kind of stuff, and with manufacturing going the way it is today, I'm quite frightened about it.
So you're going to close this valve.
There, would you like some help with
Close that
that?
valve.
Yeah.
Well, this is a working set of boat locks. Shows the idea of how people built lock chambers to run back and forth from things. If you had a river situation and you couldn't run the boat down the river, then you could build a set of locks and get around the dams there. This particular model was built because, like a lot of other things that happen, you get a request from, in this case, somebody like Mystic Seaport Museum was having a big exhibit on all the different uses of water and knew about the model sawmill that I had, so they borrowed that. And they said, well, gee, could you come up with a set of working boat locks? And so in a very weak moment, I said, oh, sure. And they said, in 4 weeks? And I said, well. So the idea was to try to build something that was a fairly generic system, but that would show all of the how the mechanism works. And of course, for the benefit of children, you build something from the side like that, then you can look through and you can actually see how the water rises and lowers in the different lock systems, and the big tubes that allows the water to go around the gates. So the idea with this is if you can get the water to be the same level on both sides of the lock gates, and you open up the gates and float the boat into the first chamber, you close those upper gates there, and you also close the valve that allows the water to go around that gate. And then the next step would be to open the valve that allows the water to drain out of the first chamber down into the second chamber. It's a little bit like pulling the plug on the sink. You just let the water back out, and the water will eventually drain down to the same level there. When the water's down at that level, you can run the boat down into the next part of the chamber, and then again we close the valve on that part and we open up the last valve. And this is all gravity fed. Water is not pumped anywhere in the system. It's exactly the way things work even in the big Panama Canal locks. It's all water that comes from the center, from the freshwater lake in the middle out through to the oceans on both ends. Once the water is down at the level in the lower part here, if this is a river, you just keep going off. If it's the ocean, of course, you keep going there. Now, as far as getting back up, the process is simply reversed, but again, it's all due to water coming out of the middle. And you can close the gates up there, close the valve. This time we're going to need a little bit more water from the upper parts, so we're actually going to open up both the middle valve and the upper valve. And if we do that, then the water from here will flow through the first chamber and fill the second chamber up. When that gets fairly close to the top of that chamber, it'll stop the water coming in from above. We can open up the doors here and sail from there into our upper chamber, and we're going to close this up. And then we open up the top valve, and the water can again raise the boat back up to the highest level here. Now this is a similar system to what you will see in places like Sebago, Maine, the Erie Canal, a lot of those types of locks. There are still a lot of these types of locks in many places in Europe we can take voyages through. If we're talking about the Panama Canal locks, I actually lived down there for 4 years also. The rise from the ocean to the lake level here is about 85 feet, and it goes up in 3 sets of chambers. And because there's a lot of boat traffic and they're going both ways, there are actually 2 chambers this way. The original Panama Canal locks were finished in 1913 and opened up, and originally they had one lake in the middle. Eventually they dammed up the Chagres River to provide that, and then a bit later they dammed the Chagres even further up to provide more water, because the water in that system goes into the lake in the middle and it actually goes out both ends of the country, so you can rise up from the ocean, travel through the lakes, through the Continental Divide, and back down the other end again.
I got a machine shop myself, and of course I have to buy tooling for it. So go to auctions, buy lots and stuff like that. This is just surplus what I.
Looks like most of these are drills.
Reamers.
What are they called?
Reamers.
Reamers.
Yeah.
What do they do?
Well, they're precision, to make holes precision, and with fine finish in them. To make precision holes. These are adjustable, so you can adjust them a little bit in or out. That's why they're threaded like this, so that you can adjust it. If this slides back, it'll open it up.
So it looks like you got a lot of reamers here.
I got a lot of reamers, I got a lot of end nails, I got a lot of drills.
And what are these in the box right here?
This is an old-fashioned valve seat cutter. This is to cut the seats and the valves. This is your cutter here. It goes on one of these. And you got the crank handle that goes on it. It turns it. That's it on it.
Interesting.
Turn it. Get in. Go this way. And these here screw right on the end of it.
So these are all fully functional.
Oh yeah.
Okay.
Oh yeah.
They're sharp and I can use them if I wanted to.
Yeah. But many of these have never been used. I mean, where would you find a valve this size?
I don't know, because I've never tried to find one.
You know, it's probably, you know, a diesel engine on a train or something.
I see.
Might find it.